Good morning. We are going to be doing a quick introduction here of what is inside the Earth and how we know what is there. So we're looking at Earth's interior right now. The standard that we're looking at is that the composition and properties of Earth's interior are identified by, and then our words we're going to fill in here. We have seismic waves. Scientists have never been to the center of the Earth. The only way that they know what is down there is by how seismic waves, which come from earthquakes, how they got there, or how they react once they get in there, just like sound moves through walls. So how do we know what the interior of Earth is made of if we can't get there? Here are some things that we do know. Layers of the Earth and the composition of the layers. So what layers there are and what they're made out of. Scientists have also used thermal energy. Oops, sorry, wrong slide. They've also used thermal energy to make predictions and gain understandings about what's going on down there. They've used their knowledge of convection currents, how matter moves in a fluid, to help them determine what is going on with inside the Earth and on the Earth's surface. And the last one, like I just said a second ago, seismic waves. Those seismic waves they bounce through the Earth, they reflect, they travel quickly, they bend, all this cool stuff that they do inside of the Earth help us see what is actually inside the Earth. See without being there, almost like echolocation. So first thing we're looking at, how do they know what the interior of the Earth is made of? So here's some definitions we're going to pop in here. We have the four layers: the crust, mantle, outer core, and the inner core. Seismic activity. The way that the waves from an earthquake move through the Earth's interior. The person or the scientist that studies this stuff is seismologist. When we look at the seismic data, seismographs give us the, let's see if I can spell it right. Seismographs are like the, almost like a chart that could be printed out to kind of help us understand and see how the waves moved, what happened from all of that. And then the last one, the instrument that get used is a seismometer. And just like you've probably seen it with the little pen and the needle are going to jump and move and dance and sway while earthquake is taking place. It's the seismometer is the name of that tool. So where do seismic waves of an earthquake originate from? Well, just like if I went out to a backyard or my pool or a pond or a puddle and I threw a rock in there, it's going to make a splash. It's going to make a wave. So when earthquakes happen, they make a splash, they make waves, and it sends out these waves in all directions. So vibrations in the ground, that's an earthquake. It results from the movement of breaks along Earth's crust. The first thing that goes out, primary waves, those are called P waves. And the secondary ones that are going to go out, bet you can't guess it, it's called an S wave. P waves, they move, it's like a push and pull, almost like if you're pushing a doorknob or pushing a door open and shut. And then S waves, those are move up and down, almost like you're waving a bed sheet across your bed or your blanket. And then the last one, those are surface waves. They're very slow and they move the ground up and down. Oops, sorry. They make the ground move up and down like ocean waves rolling. Something to think about. So the main idea with all of this, 20 seconds left. Let's see if I can do this. The primary and secondary waves, if you're looking at this chart, you can pause it and look at it, but the primary and secondary waves move through the Earth similar to how sound moves through walls. It slows down, and then when the S waves get to the core, they are stopped. All right, that's the end of this video. I'm out of time. Goodbye.